Okay, so I think people are trickling in. Going back, guys, I am not going to draw diagonals. Why? Because it'll take too long, and I want to understand how the principle works. So I will draw a few things. I will write down a few things, though. I have 8 points, and through each of the 8 points, I can draw only 5 diagonals. I'm going to write 5 instead of 3 that we had in our 2. So through each point, I can draw 5 diagonals. I'm just going to show you why that's the case. I can't connect this point to itself. That's not going to give me a diagonal. I cannot connect this point to this point and this point. So out of 8 points, this is a good point, good point, good point, good point, good point. And you can say the same thing about any other point. So through each point in an octagon, 5 diagonals can be drawn. So it's always the number of sides minus 3, just like before. So 5, 5. Eventually, you don't even have to do it. You can do it in your head. I'm going to show you a formula. Okay, through each point, I can draw 5 diagonals and there are 8 points. So it better be 8 times 5. Well, that's not good enough. That counts every diagonal twice. And 5 times 8 is 40 divided by 2 is equal to 20. So the answer is 20. It is 5 times 8. There are 8 points. Each point can be connected to or can have 5 diagonals coming out of it. You multiply it by 5, but each diagonal, your technique will count each diagonal twice. For instance, this red diagonal will be counted as this point's diagonal. This will also be counted as this point's diagonal. This is true for any diagonal. So you're going to say 8 number of points times 8 minus 3, that's 5 divided by 2. That's our general formula. I'm going to pause there just a little bit, guys. See if people have any questions. Don't be shy. Just ask that I don't get this, why you're doing this. Unmute yourself and ask. Okay, guys, so let's come up with a general formula. Okay, let's say it's not an octagon, it is an n-gon. What's an n-gon? N-sided polygon. I don't know what n is. If I have an n-sided polygon, I won't be able to draw the polygon because I don't know what n is. So I'm going to draw parts of it, or at least a small part of it. Let's say this is my polygon. Okay, there are n of them. Now, don't forget the number n. Through each point, how many diagonals can I draw? It'll be n minus 3. Why n minus 3? N minus 3 because a point cannot be connected to itself and it cannot be connected to its next door neighbors. So I don't know how many times I'll write n minus 3 because I don't know what n is, but just a couple. There'll be n minus 3. So it'll be your number of diagonals. There are n points, put n, and then you can say n minus 3. And don't forget to divide by 2. Why are we dividing it by 2? We're dividing it by 2 because each diagonal is being counted twice in this formula. So this is your general formula for number of diagonals for an n-gon. Let's pause there just a little bit. If you remember this, you can write it down, and it's easy to see why that works. All right, guys. Again, if you have questions, you can always interject, say, I don't get it. Can you explain that again? So what we're going to do, we're going to go back to your text and do a few problems, and you'll see they're not that difficult. And one more thing, guys, there is a topic in 11.2. It's called symmetry, which we didn't cover today and we won't be able to. We will do it next class, symmetry. So we won't be wrapping up our section today, and that's okay. So I want to go to the book. That's what I'm trying to do. Okay. The document that I'm opening is in your homework from text folder, and we're looking for these problems, and we'll see if we can find them. All right, so here are the problems I have assigned from your book. Now, if I run into anything about symmetry, I won't do it. Okay, this is a good problem, guys. I think I assigned you number one. 1 through 3. Yeah, let's do this. Let's do this one, the first one. Again, they're just testing if you understand what these words mean. That's all they're testing. I'll do 11.2a mostly, 11.2b are parallel. So take this, bring it here. Which of the following figures are convex and which are concave? Now, you cannot find 2 points inside that can be connected, and the line connecting 2 points will be outside. So this is convex, has no dents. This is convex. I'm going to write it right here. Convex. This shape has no dents. This is also convex. Part C, this has no dents. Okay. B is concave. I'll tell you why. B is concave because there is a dent right here. The dent is right here. I can take a point here, and connect it. This line will be at least partially outside the shape. This is also concave, arguing exactly the same way. I can take a point here and a point here inside. The points are inside the shape, but the line connecting the points are at least partially outside. And I can clearly see B and D have dents. A and C have no dents. That takes care of question one. Just going to pause just a little bit for you to process, but I think I'm recording. I'm going to double check again. Yes, we're recording. Just to let you know, I will keep you guys muted, but if you have any questions, You just unmute yourself and ask, no problem. And if I don't mute you, what you can hear, I hear it back. So we just applied two of the words that we learned today. All right, let's see what's next. I won't do all of them. They're very repetitive. Okay, this is a good one. Can a regular polygon be concave? I would say no. I'll tell you why I'm saying no. It's it's actually a challenging question, but looks very simple, right? Mhm. Remember, guys, if you have a regular polygon, all sides, all angles are going to be the same. Okay? The example or an example is a square. Another example is an equilateral triangle. Now, if you make a dent, guys, what happens when you put a dent? If it's supposed to be concave, you will need a dent. Let me get rid of this whole problem. Okay, if you create a polygon with a dent, this is a dent, okay? It will never be regular because this angle will be bigger than these other angles, okay? Wherever you have a dent, this angle will be bigger than all the other angles. So in a regular polygon, all angles are supposed to be the same. If you have a polygon with a dent, all angles will never be the same. The dent will cause the inside angle to be way bigger. So that's my explanation to number two. Okay? And here is your problem number two. That's my explanation. I will just ask you if this is true or false. I'm not going to ask you to explain it, but you should know that a regular polygon can never be concave. It will always be convex. I'm just going to pause for a few seconds, okay? Okay, let's see what three is like. Determine which of the figures labeled. Okay, I will just do it right here. So they're saying simple closed curve, polygon, convex polygon, concave polygon. We can do it. Okay, these are the shape. Okay, this one is the number one is a concave polygon because it has a dent. Number two is not simple, but it's closed. This curve is not simple because it crosses itself. It's closed because it doesn't have loose ends. C is two different curves. Okay, so C is none of those. By C, I mean three. Four. Four is a simple closed curve. It's simple because it doesn't cross itself. It's closed because it doesn't have loose ends. Number five is really two curves. There are two triangles that are overlapping each other. Okay, Molly, let's see.
Why is number four closed? Because I
Sure.
see two loose ends on it.
Good question. Good question.
Oh,
Okay,
wait, I see it now. It's
tell
because
me
it's the letter C.
exactly. If you look at the letter C, it is not closed, but we are not looking at the letter C. To us, the picture is more like this. That's a good question. Very good question. The picture is actually more like this. That's all we care about. Do you see that?
Yeah, it was just confusing me because I was
I totally
thinking of the
understand.
letter.
Totally understand. Yes. Okay. Six is a simple closed curve, and it is a convex polygon because it is a polygon without a dent. Polygon is a closed shape bounded by straight lines. Number seven, same thing as six. It's a simple closed curve. Simple because it doesn't cross, closed because it doesn't have loose ends. It's a polygon. What kind of a polygon? It has no dents. It is a convex polygon. Eight is the same thing. Okay, nine is none of those. It's two curves sitting next to each other. Okay. This one is, it's not a simple closed curve because it is really two shapes, two polygons connected by a line. I'll pause here just a little bit for you to look at the picture and decide. I could easily give you problems like this on the exam. I'll give you a picture and say, just like your book says, decide which ones are applicable. Simple closed curve, polygon, convex polygon, concave polygon. You have to choose the best one. Or you can choose multiple of them. I don't care. I don't think they're being very specific, but either way, you get the point. Let me see what else is coming up. I want to do one with sides, diagonals, 8 through 13. Okay, this is a good one. Identify each of the following triangles. Let me see. Molly, do you still have questions? By the way, I'm talking to everybody. You can raise your hand or you can just unmute yourself, and I won't consider it rude. You can unmute yourself and ask, I have a question. That's totally fine. Sometimes, good, thank you. Sometimes I don't see the icons. It's a little box that shows up just to let you know. Just unmute yourself and ask your question. It's not a problem. I'm aware that you guys are here. Okay, let's do number A. It's very much aligned with what we did today. Just a direct application of some of the things we did. All right, this one. Identify each of the following triangle as scalene, isosceles, or equilateral. There may be more than one term that applies to these triangles. The first one, number part A, is A is equilateral and isosceles both. They're saying you have to use more than one term if you have to. Or isosceles. That's the first one. This one is only isosceles. Two of the sides are the same. The third side is different. So part B is isosceles. Part C is scalene, clearly saying AC is bigger than BC, BC is bigger than AB. Scalene, they just want to see if you know those words. Okay, that takes care of number 8. So these problems are not that difficult. We have done harder things in this class. Let me go back. 8, 9. Okay, let's do one of these. Okay, I'm not going to do all of them. I'm going to do maybe part C. We spent a big chunk of time today, okay? So I don't know if I have to draw the picture, but we'll see. So I'm going to do part C only. We have done the one with N. We have done the one with N. Okay. How many diagonals? The polygon has 20 sides. Through each point, I can draw, through each point, I can draw 17. 20 minus 3 diagonals. There are 20 points, so multiplied by 20. And that is not correct. You have to divide it by 2. And if you use your calculator, you're going to get 170 diagonals. Part C, answer to part C is 770. Decagon is 10-sided polygon. Pentagon is 5-sided. N-gon is n-sided. Let me do that one with n again, without a picture. Okay. So what is this one? Let me mark this C. This one is going to be D. N sides, so start with n points. Each point will give rise to n minus 3 diagonals. And you better divide it by 2 because this technique counts each diagonal twice. So we did C and D. So here's the deal, guys. Let's stop here. Let's stop the lecture here. I talked for almost 55 minutes. I will be happy to take questions, not a problem. Next class, which is Thursday. Thursday, I am sure we'll be able to wrap up 11.2. And we have to talk about symmetry. And there are two types of symmetry. And symmetry is a very important topic because you will be teaching it. And if you take GACE, you will be examined as well. So we'll wrap up next class. I'll be happy to take some questions, guys, if you have any. Now, if you don't have any questions, feel free to leave. I'm going to be here till the last person leaves. Thank you, guys. Thank you for coming.
I have a
Sure.
question.
Yeah. Molly, what's your question?
So when it has a dent that is going outwards and not curving inwards, would we still consider that concave?
Good
Because we can
question.
still draw a line.
I know what you're saying. Look, if I understand you right, a dent always goes inside. Okay. A dent always goes inside. For instance, to me, this is a dent.
Yeah.
Okay. Now, you can call this a dent because it's going outside. Dent goes inside the polygon. So this is a polygon that's convex. And now you can actually, if you're, I don't know how comfortable you are with Zoom, you can actually draw. You can draw something on your screen and share with me. Let me see.
It says I can't during screen share. But I was talking about the problem that
Oh,
was the
okay. Go ahead. Go
rectangle.
ahead. Do you want to draw now? See if you can. See if you can share your screen, draw a shape.
Mm, It's loading. All
Take
right,
your
here we
time.
go.
Take your time.
So I was talking about the problem that was kind of like this, and then it had a dent outwards. So
Okay.
I was wondering because it was similar to like this
I
because we
see.
can
I
still
see. I
make
see.
it into a
Okay.
larger shape.
Good question. So just the extra line you added, that was not a part of the shape, the L you added, right?
Right.
Get rid of that if you don't mind. Okay. I would say this has a dent and this is the dent,
Mm-hmm.
not the outward dent. This is a dent. And
Oh, okay.
and why is it consistent? Firstly, it's a dent. Secondly, I can take 2 points that are inside your shape and I can connect them and the line will be outside.
Okay. Yeah.
So the question is, it has a dent, but not the one you're referring to.
Mm-hmm. Okay.
Does that answer your question?
Yes, sir.
Good. Very good.
All right, that was it. Thank you.
Wonderful. Thanks for asking your question. Bye bye.
Bye. Have a great day.
You too.